All right, today we're talking about describing angle pair relationships, and we have a lot of vocab to discuss first. First off, we have complementary angles, and when we're talking about complementary angles, we mean two angles that add to 90. These angles can be stuck together or pulled apart, but as long as they add to 90, then they're complementary. We also have supplementary angles, and once again, these two angles are supplementary if they add up to 180 degrees. And these two could add up to 180 degrees. They can be apart or they can be stuck together. And notice, when they're stuck together, they form a nice straight line. Key thing, though, is they add up to 180. One quick way to remember this is in the alphabet, C comes before S. And when we're counting in numbers, 90 comes before 180. So C comes before S, 90 comes before 180. You should be able to match them up. The next thing is adjacent, and I haven't really talked about it, but we've seen it up here. When two angles are stuck together and they share a side and a vertex, then they're adjacent. When they're not stuck together, like these two green ones, then they're non-adjacent angles. A linear pair is the next topic. When two angles form a linear pair, they are stuck together and they make a straight line. Some examples come from this picture, and you can see we've listed them over here. We listed that angles 1 and angle 2 form a straight line and they're stuck together. Therefore, these two angles are a linear pair. We've also listed out a lot of other pairs. Vertical angles is the last term. The cool thing about vertical angles is they're usually formed when you make a perfect X. They're across from each other and they're the same size. The neat thing is that they make the nice little letters V and A, standing for vertical angles. You can also take the picture and you can rotate it and once again make a nice little V and A. And that would kind of look like this, V and A. It's just stretched out a little bit more. Still pretty neat. All right, so in example 1, it says in the figure, name a pair of complementary angles, a pair of supplementary, and a pair of adjacent angles. If you remember, complementary angles add to 90. So we got to find two numbers in here that add to 90, and those would be located here and here. All you have to do, though, for complementary angles would be to name the two angles that are complementary. The key thing, the vertex letter must be in the middle. So I would name that one A, B, D. What's the other one that is a complement to it? Oh, it's over here. You could name that one maybe B, D, C. Following that, we could have our supplementary angles, and I'll write that over here. What's supplementary mean again? Supplementary means they add up to 180. So what two numbers add up to 180? 128 and 52. I need to name those two angles. So we'll call that one A, B, D. And the other one, I would say, that would be a good name, B, D, E. The last one at once, adjacent angles. And those are angles that are stuck together. They share a side and a common vertex. So adjacent over here would be these two angles that are stuck together. And we could name them CDB. And the other one could be named BDE. That's an example naming. Key thing you got to remember about naming is that I can switch these outer letters as long as I keep the vertex letter in the middle. In example 2, it says, given that angle 1 is a complement of angle 2 and measure of angle 2 is 57, find the measure of angle 1. The key thing about complements you have to remember is that these two angles are going to add up to what special number? 90. Therefore, angle 1 plus angle 2 are complements, so they add up to 90. Then I can use the idea that angle 2 is 57 and substitute. Subtract 57 from each side, and what do I get? When I subtract 57 from each side, I get 33. Thank you. All right. Supplements are done the same way, except you change the 90 to a 180. So once again, supplements mean add to 180. These are the things I'm adding to 180. So I'll say angle 3 plus angle 4 add up to 180. And it tells us angle 4 is 41. Substitute. The simple math from there is subtract 41 from each side. When I do that, what do I get for the measure of angle 3? 139. Thank you. All right, the neat thing about a lot of these checkpoints is they match up exactly to the example with the same number. So this most of the time will match up with example 1. Most of the time will match up with example 2. Not all the times. I don't think example 3 matches with anything because we haven't gotten to example 3 yet. So this checkpoint won't match to example 3, so be careful. Most of the time it does, though. Let's do number 1. It says in the figure, name a pair of complementary angles, supplementary, and adjacent angles. Which ones are complementary? The 50 and the 40. So we have to name them. So I would say the complementary ones would be angle DEF. And what did you all say? ABC. That's exactly the same names that I would use. The next one says supplementary, meaning add up to 180. Which numbers add up to 180? 140. Okay, so I need to name those two angles, the one with the 140 and the 40. So how do we name the 140 one? FEG. I would do FEG or GEF. And its corresponding supplement would be ABC. The last one says a pair of adjacent angles. So adjacent means what? Stuck together side by side. Oh, so those would be these two over here, the 50 and the 40. We just have to name them. I would say angle DEF and angle FEG. Number 2 says, given that angle 1 is a complement of 2, and angle 1 is 73 degrees, find the measure of angle 2. We just did this kind of problem in the examples. So, the key thing, complement means what? Adds to 90. So we're going to say angle 1 and angle 2 add up to 90 degrees. That's what I'm going to write over here to the side. Angle 1 plus angle 2 should add up to 90. And I'm going to substitute what value? The 73 goes in for angle 1. Subtract the 73 and we get 17. Good. Similarly, we can do this one for the supplement. So the supplement will mean adding to 180. So we'll say angle 3 plus angle 4 should add up to 180. Angle 4 is 37, so we substitute it in. Subtract 37 from each side. And what do we get? 143. Good job. Example 3 says the basketball pole forms a pair of supplementary angles with the ground, but it wants us to find the measures of these two angles. So we have to really pay attention to what we do at the end. First thing we're going to do is realize that we have this math word, supplementary, which means adds to 180 degrees. So I know that these two angles will add up to 180, and you can see that's noted by the straight line in the picture. I can then substitute values. Which one is BCA? Yeah, the expression 3x plus 8. Which one is DCA?
4x minus 3.
Good, and they still are supplementary. Now you need to do some algebra. You need to combine like terms. 3x and 4x are like terms. Add them together and they are 7x. You also have some constant terms. You have an 8 and a minus 3, which is a positive 5. And then you have a two-step equation. You need to move two terms to get the x alone. Which term should I move first? Move the 5. How do you move positive 5? Subtract 5 from each side. And you're left with 7x equals 175. You then can divide by 7. When you divide by 7, what do you get for the value of x?
25.
You get 25. The common mistake at this point is that a lot of people will stop here. They'll say x equals 25 and they think they're done. But you need to remember, I stressed this earlier, it says find the values of these angles, meaning we need to take this value and plug it in for these two expressions. I can do this mentally. 3 times 25 is 75, and 75 plus 8 is?
83.
That's an 83-degree angle. So BCA is 83 degrees. I can do the same thing over here on the other expression. 4 times 25 is 100, and 100 minus 3 is 97 degrees. So DCA is 97 degrees. Once again, this next checkpoint works with example 3, and you'll have to substitute values. The only thing that changed were those expressions noted. If you remember in the last example, they said they were supplementary. Therefore, these two expressions are supplementary, meaning they add up to what special number?
180.
Okay, so I'm going to say, once again, blank plus blank equals 180. That's a good start. If you don't have that, you might not know where to go from there. Here's the first expression that I can bring down, 5x plus 1. The second expression is 6x plus 3. Combining like terms on the same side, 5x's plus 6x's is 11x's, and 1 plus 3 is 4. That all equals 180. To get x alone, we need to subtract 4 from each side, and we get 176. We need to then divide by 11, and we get 16. A lot of people stop there, but that's not cool because you're supposed to find the values of those angles, meaning you need to take that number and substitute back into each expression. So we have two expressions we're going to have to substitute into. The first one is that 5x plus 1, so I can write that out. 5 times 16 plus 1, and what do we get? 81. Sorry, I wrote 80. The other one is the 6x plus 3, so that's 6 times 16, then add 3, and you get 99. So the value of those two angles are 81 and 99. 81 and 99. In example 4, it says identify all the linear pairs, all the vertical angles. So first I'm going to write the letters LP to stand for linear pairs. I'm going to list out the linear pairs over here on the side. Remember that linear pairs together make a straight line. It's two angles stuck together that make a straight line. So which two from the picture are stuck together making a straight line? One. I would say 1 and 2. And in the picture we can see that 1 and 2, if I outline them both together, they make a straight line. So they are a linear pair. Are there any other linear pairs? Yes. 1 and 5. Well, let's look at those. All right, they are stuck together, but do they make a straight line? Not exactly a straight line. Good thought, though. Yes?
1 and 4.
1 and 4. Are those two angles that make a straight line? No, I see 1, 2, 3 angles to make a straight line. Another common misconception. Pair is 2. Yes? 2 and 3 is the last and final answer. Once again, you have two angles stuck together and they make a straight line. 2 and 3 would be your answer. Vertical angles, I think, are the easiest type. For some reason, a lot of people miss these, though. Vertical angles make that perfect X. They're across from each other and they're the same size. Do we see any vertical angles? Which ones are vertical? I heard 1 and 3, and I definitely agree because you make that perfect X, and they're across from each other, and they're the same size. 1 and 3. Are there any others? Are there any other vertical angles? Yes?
No.
There are no there are no other vertical angles. Common misconception would be this: 2 and 4, but they don't make that perfect x. You can see that you can't really even fudge it to make a perfect x. So no, there are no others other than 1 and 3. Go down and try the next checkpoint and see what you can do. On the checkpoint, let's first work on the linear pairs. So we'll write our LP out to the side, just like we did earlier in our example. Linear pairs are two angles that are stuck together, and only two angles that will make a straight line. A lot of people try to say this is a straight line, but how many angles make it up? Three. Therefore, it's not a pair. Some people say these are stuck together, but do they make a straight line? No. So we have 0 linear pairs. There are none. A lot of people miss that. The next one is vertical angles. On vertical angles, we should have a few. Remember, they should make a perfect X. They are the same size. They are across from each other. Who can give me one vertical angle?
2 and 5.
2 and 5. And let's check. 2 and 5, are they across from each other? Yes. And did they make that perfect X? Yes. Therefore, 2 and 5 are vertical angles. Are there any other pairs? Go ahead, Anna. 3 and 6 across from each other make the perfect X? Yes. Any others? Yes. 4 and 1 across from each other make a perfect X. Great job. In example 5, it says 2 angles form a linear pair. The measure of one angle is 4 times the measure of the other. Find the measure of each angle. This is just like you've seen in Algebra 1. So we can envision this as we don't know the value of one angle, and we really don't know the other one other than it's 4 times the other angle, 4 times x. Those are the 2 angles that we have. The key thing you should know is they're a linear pair, and linear pair adds up to 180. Therefore, these two values add up to 180. So we can say x plus 4x is 180. Combine like terms, x plus 4x is 5x. And calculator time, 180 divided by 5. What do we get when we type that in? 36. Does that answer the question? Find the measure of each angle. It answers one of them. One of them is going to be 36 degrees. To find the other, substitute in and you get, use your calculator, 144 degrees. Those are your 2 angle measures. For the last one, we have 2 angles that form a linear pair. The measure of that one angle is 3 times the measure of the other, meaning that one angle is an x, and the other angle is 3 times that value, meaning they will add up to 180 degrees. 1x plus 3x is 4x. Divide by 4 on each side, and you get 45. When you substitute that back into each of these expressions, you're going to get that one of them is 45, and the other one is 3 times 45, which is 135. So I could just note it like this: 45 and 135. For the concept summary, we can see that all points shown are, and this is a review word, they are on the same paper, so they are coplanar. So I can write that out. We can see that points A, B, and C are in a straight line, therefore they are linear or collinear. And B is between A and C. The last ones concern these 3 crossing at point B. That means they intersect at point B. DBE and EBC are over here, and they're stuck together, therefore they are adjacent angles. And ABC right here is a straight line, therefore it is a straight line. or a straight angle, you could also say. Point E lies in the interior of DBC. And you can read the rest on your own. It tells you what you cannot conclude